Here we will demonstrate how the IP67 module works in TIA Portal to communicate with the Siemens S7-1200 PLC step by step. First, we need to prepare the GSD file for the IP67 module as well as the programming software. Open TIA Portal. Create a new project. Then click Create. After creation is completed, click Project View. Then click Online Access. Select the PC network card connected to the device. Then click Update Accessible Devices. Here you can find the PLC in the IP67 module. Then expand the list. Click Online and Diagnostics. Then open Functions. Here you can set the PN device name of the module. For example, we change it to IP PN 8i. Then click Assign. After assignment, click Update Accessible Devices again. Now you can see the module's IP device. Find the device, name the IP and device name. Then click Options. Click Manage. Then select the GSD file. Then install it. Then click Close. Wait for the software update to complete. After the update is complete, the next step is to add the PLC. Click Add New Device. Then select the PLC model. After adding, directly click Network View. Click Other Field Devices. Click Profinet I/O. Click ODOT. Drag in the I/O Link Master module. Then assign it to the PLC. After assignment, double-click the module. Delete all disabled ports. Since my master station connects to the IO-Link slave via port 1, I need to use slot 1 to add the IO-Link slave instruction block. Add the IO-Link slave instruction block, add 8 DIP 8 DOP. Then the other 7 ports can be configured as input or output. We set pin 4 as a standard output. Then add them all. Then click Function Submodule. Here you can add diagnostic modules. For example, we add Event 1. 01 means only diagnosing the first slot. Then add Input Process Data Valid. Then add Communication Error Status. After adding, we can click Reload. Then click Properties. In the module parameters, you can set the communication baud rate. We can use the default 38400. Further below, you can set when a fault occurs whether the channel holds the last value or outputs a fault value. Below you can set the fault value. Then click pin 4 of the master station. This is also in the module parameters. Here you can configure pin 2 as input or output. Here I choose input. Then pin 4 we set as output. Here you can set it as PNP or NPN output. We choose PNP. Then click Event. Then Event Source. It only diagnoses one port. Here we can choose to diagnose the master or the 8 ports below it. We select the master. After configuring the submodules, double-click the master. Set its IP here and its PN device name. The PN device name must match the one in online access. Modify it to be consistent. After modification, we can compile and download. First, compile. Then click Download. Click Download again. Then click Load. Then click Start Module. Then click Finish. After downloading, you can see the master module status indicator is normal. But the slave module's UA LED is still flashing, indicating it lacks auxiliary power. So we need to provide output to pin 2 of the master to supply auxiliary power to the slave. Then click Online. Open the watch table. Create a new watch table. Enter the master's I/O addresses here. Then click Monitor. We give the master module an output on port 1 pin 2. Now you can see the slave module's UA LED is steadily on, indicating auxiliary power is supplied. Now, for example, I output 8 points on the master. You can see all 8 pin 4 outputs are active. Then we give an input to pin 2. We give input to the last port module. You can see the last bit of IB68 is on. Then we give an output to the slave module. You can see the slave module's 8 points are also output. Then trigger an input. Pin 4 of port 4. Here you can see the last point is also output. Then we perform event diagnostics. For example, check event 1 first. Event 1 occupies 2 words. Disconnect the slave. You can see here an error code pops up. The code 1800 needs to be checked in the manual. The manual describes it as port communication error. The byte 00 has no actual meaning. The 2 indicates a warning. The 1 indicates the port number on the master. Since the slave is connected to port 1, it shows as 1. Then monitor input process data valid. All values are 0, meaning all 8 ports have invalid input data. Port 1 becomes 1, indicating port 1 communication is valid. Then monitor communication error status, IB76. Normally, all 8 ports are 0. Here the value changes from 0 to 1, indicating port 1 has an error. End of demonstration. Thank you for watching.